A combination is used when grouping items in a set. So the key here is grouping, like we're collecting items. So whenever you're grouping items, the order doesn't matter. So it doesn't make a difference how I group these items. So this is the weirdest thing, I think, about combinations. So you guys have heard of like a combination lock that are on lockers that you have to like turn to put your combination in. I think it's weird that they call it combination because a combination, the order doesn't matter. So technically they should be permutation locks because the orders matter. So a combination lock, don't think about those when you're thinking in terms of mathematic combinations. Combinations just mean the order doesn't matter. And we have difficulty with this type of grouping. And the reason we have difficulty with it is because we like to put our personal feelings in the problem. So the thing that you need to remember about these mathematician people in these problems, they have no feelings, they have no emotions. You're not going to hurt their feelings if you don't invite them first and you invite them fifth. It does not matter. So like the combination people in the problem, they don't care that you didn't invite them first. They have no feelings, okay? And it doesn't matter, like if you're putting items on top of a pizza, it does not matter if you think sauce should go first and then cheese. In these kinds of problems, you're just putting it all together and there is no personal feelings in the problem, which makes these problems a little harder because we like to give these people in these problems emotions and feelings, and we think, oh, well, that would hurt my feelings if I wasn't invited first to a concert. It doesn't matter in these problems, okay? These people are heartless. They have no feelings. So some examples. The first example of a type of combination is, let's say you're missing all of your homeworks. Some of you are missing all of your homeworks. You should do them. But let's say you're missing all of them, and you just need to accomplish a few of them. It doesn't matter which one you do first or last. So that would be a combination. So any form of completing I just realized I cannot spell. I added an E. Okay. Back it up. I was looking at that word. I was like, that doesn't look right. All right. Completing X number of assignments. So like you have 10 homeworks that you're missing. You want to do 5 of them. It doesn't matter which one you do first or last. You're still completing homework. Okay? It does not make a difference. You don't worry about deadlines, things like that. Another one is choosing a person, or choosing people, I guess we should say, it'd be plural, for the same office or position. So like, if you're picking 5 class representatives, all of you are the same level of people. So it doesn't matter if you are the first class representative or the 5th class representative to be chosen. You're the same level. All of you have the same power. So it doesn't matter if you're first or 5th, you're still a senator or a class representative. So the order doesn't make a difference, okay? Next, how to order food. So it seems kind of silly to like go over how to order food, but in these problems, it could say, okay, you're putting toppings on a burger. It doesn't matter if you say, I want lettuce, tomato, and onion, or if you say onion, tomato, lettuce. Like, it doesn't make a difference. You might have a preference in your real life, like you don't want the bread to get soggy, so you put lettuce first or whatever. But in these problems, that doesn't exist. They don't care. There's no feelings that are being hurt, okay? So just be mindful that the people in these problems, they don't care if you pick them first or last, okay? There's no certain way you have to do these problems. So combinations can be hard because we put feelings into the problem when we don't need them. Okay? The formula for combination looks very similar for permutation. So the formula for combination, your calculator is going to look like this. Little n, big C, little r. So it's just like permutation, but instead of a C, it's an R, or a P, it's a C, sorry. Our formula is still n factorial over n minus r factorial. But now we have an r factorial out by the side. So like this part is permutation, and then we add the additional r factorial. So we talked about factorials on the other page. And we also talked about what the n and r value stands for. So if you want to write it again, you can. Like I'll write it over here. But we did write it on page 7. So n represents the total number of items to choose from. And we did write it on page 7. So if you don't want to write it again, you don't have to. The letter r represents the number of items or things to be selected. And when we're working with the n and r value, n always has to be greater than or equal to r. For example, if there's only 5 toppings to pick from on my pizza, I can't order 7 toppings because there's only 5. So I have to remember when we're working with these problems that n can either equal r or be greater than r. Okay. Now again, your calculator does this formula for you. You don't have to have it memorized. You don't have to have it memorized. As far as permutations and combinations go on the ACT, you'll see that it's mostly just use the right formula. Okay. Some of the problems, just like before, it might be easier to not use the formula, okay? So some of the problems, you might not want to use the formula, and that's okay. Okay, it just depends on the type of problem. So for the calculator steps, they're very similar to the previous ones. So apparently, I just found out because Marida has an 84 plus, and I've got the 84 plus C, and they're different. So the type of calculator, if you have the 84 plus CE, like the color edition, you go to math, over to probability, but instead of choosing option number 2, when you go over to probability, you're going to choose option 3. Option 3 will be the C, which is combination. So you're going to have to remember that you're picking option 3. And then you're going to type in N and R. And then press enter, obviously. Okay. But if you have literally any other type of calculator, like an 83 plus or an 84 plus, you have to type the N value first. Then you go over to math, and your probability is PRB. And instead of choosing option 2, you still pick option 3. And then you do your R value. So it's a little bit different. And again, you'll get the hang of it. It just depends on what kind of calculator you have. So if you're trying to use the color addition calculator steps on an 84 plus or an 83, it's not going to work. You have to put the N value first. And you'll recognize it whenever you type it in. You're like, hey, I can't fill in these boxes. Okay? So our first problem, we're going to use the formula. Remember, using the formula is very helpful. Your calculator will do it. So this problem says how many combinations can you invite 3 of your 5 friends to a concert? So here's the part where it can be tricky. In our mind, we like to think, well, I would invite my best friend first, and, I would have my feelings hurt if I wasn't picked first for this concert. In these problems, like, these people don't care. They have no emotion. They're not going to be happy that you picked them first. So it's very tricky because you have to take your personal emotions and feelings out of the problem. In these problems, the people don't care if you pick them first or last. They're just happy that you invited them to a concert. So the order does not make a difference when you invite your friends. So in this problem, you only have 5 friends, which is okay. You don't have to have a bunch of friends. So in these problems, you've got 5 friends. So your n value is 5. That's how many friends you have to pick from. So my n value here, I only have 5 friends, which is okay. I'm just inviting them to a concert. They're all on the same level. So this is going to be a combination. And I can only invite 3 of them. Like only 3 of my friends can come. Again, it doesn't make a difference how you invite them, what order. So it's not a permutation, it is a combination. So to type it in on the calculator, I will use the older version to make it a little easier. 5 goes first. Math, go over to PRB, which is probability. And then down to option 3, it says NCR. Click it, and then put 3. Your calculator knows, okay, this number is first, that should be N. This number is second, that should be R. Like your calculator already knows that. So there are 10 different ways you can invite your friends. So the answer is 10. Okay. All right, so try the next 3. Again, these are all combination problems. Our first practice, they're going to be mixed up together. So you're going to have to remember, does the order really matter? So try the next 3 to kind of practice typing it into the calculator. Okay. It says how many different 7-card hands can you make out of 52? So there are 133,784,560 different combinations of 7 cards you can have in a regular 52-card deck. So the numbers are going to be big. It's okay. So number 2, how many different committees of 3 people can be chosen for a project if there is 9 people in the group? So again, these people don't care if you pick them first or last. They just want to be on the committee. So 9C3 is 84. And then the last one, John bought a bunch of different fruit. He has 5 fruits, and he wants to make a 2-fruit juice drink. So it doesn't matter if you put strawberries in the blender first or oranges. When blended together, they are all the same. So 5C2 is 10. He can make 10 different juices. Okay.